So what we've done so far for a couple of lectures anyway is getting a sense of what's in the data. So that's like exploratory data analysis. Now another useful use of visualizing the data is to make a story for other people. So telling a story about the data, telling a story about your results, communicating your results. So that takes place in a second step or third step. Usually it's not because you've done that you're done here. That's a mistake that some students sometimes do, and even many researchers saying, oh, they have done this graph for myself. It looks pretty good for the rest of the world as well. I should say that it's not something that's heavily emphasized in academic settings. We spent many hours thinking about what it is we want, how to extract truth or some version of truth from the data, and we spend very little time thinking about how to communicate it effectively. So it's not something that you probably will do much of in your academic career, neither as an undergraduate nor as a master's student, not even later, until very late, where you go on the job market and suddenly we're going to bring a speech coach or something like that. And yet it's really essential. A lot of people don't spend a lot of time reading papers, and we could blame them, but it's better to take that as a starting point of the way this is the way life is. And if you want your results to have any chance of seeing the light of the day, they will need to be presented in a way that can appeal to the person who is going to spend very little attention and very little time on your production. So they cannot read very many small print letters. If you're going to present in a presentation, the presentation has to be very clear, and it actually takes a lot of time. So it's, as over the year, I realized that I've really underappreciated how important it is for students and for faculty, and to continue to have some basic set of tips about how one presents results, graphically in particular, but I'm also going to talk a little bit about tables. And as a person who writes paper, also I realize how important it is that I think for each paper how things need to be done. And that's important because there is more and more defaults that are provided to you that are not bad. But the very fact that they are default means you should run away from them. Because, for example, it's pretty obvious when you see an Excel chart that this is the default Excel palette. And the immediate thought that goes on the back of the mind of something is that, oh, it's someone who didn't even take the bother to change the color. So, and at some level, you could say, well, why would I waste my time changing the color in Excel? Someone has probably thought very hard about the optimal, color palette for the readers. But the truth is that just moving away from the default is going to signal that you paid some attention to the reaction of the readers, and that's like one small point. So the defaults for tables, for graphs, etc., are good and better, but precisely because they are default, they are not a substitute for thinking about what goes into a layout. And in addition, in reality, it is always the case that the particular story you want to communicate is different from time to time, from paper to paper, and therefore you have something different that you want to present things in a different way. So there is an emerging science of data visualizations. If you Google data visualization, you will find millions and millions of quotes. It's very cool, etc. There are even some RCTs. But many of the principles you hear about in data visualization are not based on any kind of real science, as far as I can tell. But on the other hand, it makes a lot of common sense. So what I'm going to tell you is a lot of common sense, but it's still useful to have heard it at least once. I should say I'm going to emphasize today scientific visualization, not what you would do for newspapers. If you read the New York Times, they've become, in the last few years, incredibly good at presenting visual results. They make stories, they have animated things, the tools are getting better and better. This is way beyond my pay grade, so I'm not going to present that, but I'm going to talk to you about how one would do it for very simple outline. I'm going to be talking about charts, and I'm going to talk about tables. much more about charts than about tables. There is more to say. So what's visualization? So I took these definitions from Robert Kosara, who has a blog called eagereyes.org with various discussion of what is of interest to the visualization people. And what does it say? Well, it's based on non-visual data. Visualization's purpose is the communication of data that rules out photography and image processing. Visualization transforms from the invisible, so your results, etc., to the visible. Okay? You want to produce an image, so that seems pretty obvious, but it's not always evident. And in this case, the visual should be the primary mean of communication. You could have other things like numbers and things like that added to it, but that should be the primary mean. Otherwise, it's not a visualization. So, for example, you could have a good table with color and everything. That's not visualization. You want an image. You want a graph. The results must be readable and recognizable. You must provide a way to learn something about the data. You're going to leave out some information necessarily from a big data set to an image, but there should be something left in the data. All of that seems rather common sense, but when you often, like if you take a visualization and you might fail either of these criteria. So what are we trying to achieve when we want to present a chart, a visualization? We want to show the data. We don't want to lie about it. Or rather, I would hope that you don't want to lie about the data. You can practice. It's kind of easy to lie about data in a visual form. I'll show you some examples where you can easily get misled. Of course, if you know it, then you can use it to start lying about the data, but that's not the objective. You want to illustrate your story, which is why the visualization that you're going to do in order to communicate results will always come at the end and not at the beginning. That's why it's not going to typically be the same graph that you did first, because you want to, it's only when you know what you want to say that you're going to be able to think about what needs to go in your story. You want to reduce clutter, so don't have anything that's not needed, because anything that's not needed is going to obscure the story that you want to tell. It doesn't mean you're not necessarily going to have a lot of stuff, but you're going to remove the unnecessary pieces of art. I'll give you examples soon. You want to convince, so show the data, not lie about it. You want to convince, but you don't want to convince by lying about the data, so you want to convince and you want to convey information. So although you're telling a story that is supported by the data. Another important principle, and that is true as well for tables, in all scientific journals, and actually that's true also for the New York Times, one needs to be able to read your graph without nothing else. So typically the way that people, first time that you write a paper, you're going to put a graph and then you're going to have a whole text next to it describing what's in the graph. And of course that's okay, but you need to keep in mind that someone should be able to read your graph without having read the paper. And it should be understandable what it means. Again, remember, the graph for a lot of people are going to be a substitute to writing your papers. Hopefully you want, for some people, it to be a complement, or for some people being at least an entry point into your paper. But for a lot of people, the graph is going to be the first thing. Maybe they'll read your abstract, the first few lines of your introduction, what is this thing even about, and then they'll go straight to your figure. And if the figures are not self-explanatory, then they'll get discouraged and move to the next thing. Think of people having relatively low attention span. So I'll give you some, that doesn't apply to any of you.